Hello, today we're going to be talking about solutions to linear inequalities. So there's some things that we need to know about first, and I'm going to be referring to these answers as we go through some of this work. So a point is a solution to the linear inequality because it makes the inequality true, meaning I'm going to plug in, determine if I have a true or false statement, and then that will tell me that I have a solution or not a solution. So if we have a point that winds up being a solution, it can also be a solution because it lies on the graph. So that's going to be the second half of this lesson. If it's not a true statement, then it's not going to be a solution. And the same thing, if it doesn't lie on the graph, then it is also not a solution. So if you want to pause the video right now just so you can write this down, please do so. Okay. So if we take a look at this example, x plus 2y is less than or equal to 10. We are going to determine if these points are solutions, meaning are they going to lie on the graph or not. So the first thing I need to do is identify that 0, 0 is x, comma, y. So I'm testing 0, 0 often in these two examples because that's going to be an important point later on when we start graphing linear inequalities. So let's show the work. I have an x and a y, so I'm going to plug in 0 and 0. So this becomes 0 plus 2 times 0. And we're going to see if that's less than or equal to 10. So let's do the math on the left side. 0 plus 2 times 0 is still 0. And then we need to think to ourselves, is this true? Is 0 less than or equal to 10? And it is. So since I got a true statement, that means that 0, 0 is a solution because it makes the inequality true. So 0, 0 is a solution. Negative 2, 10. So here's my x and y. I'm going to plug in negative 2 for x and then add 2 times 10 to it and determine if that's less than or equal to 10. If you need to, put the left-hand side in the calculator. That's totally fine. But you're going to wind up getting 2 times 10 is 20, minus this 2 is 18. And that is not less than or equal to 10. So this is a false statement. Since we got a false statement, that means it is not a solution. So this one doesn't work. So let's take a look at the next example. Negative 2x plus 4y is greater than 8. Let's test 0, 0. Here's my x and y once again. If I plug this in, I'm going to get negative 2 times 0 plus 4 times 0. And now I'm going to do the math on the left. 0 plus 0 is 0. Is that greater than or equal to 8? No. So since I received a false statement when plugging in this point, it means that that point is not a solution for this reason right here again. It's not a solution to the linear inequality because it does not make the inequality true. Let's try this point 0, 2. So I'm going to have negative 2 times 0 plus 4 times 2 and see if that's greater than 8. Once again, you can plug the left side into the calculator if you need it to help you with the math. That's totally fine. But negative 2 times 0 is 0. 4 times 2 is 8. 0 plus 8 is still 8. Is that greater than 8? It's not. 8 is equal to 8. Our symbol here does not indicate that I can be greater than or equal to. It's just greater than, in which case this is a false statement. So this point, although it will lie on the dashed line, which is going to make a little bit more sense when we start graphing linear inequalities, this is not a solution. And the last one, 1, 3, if I plug in negative 2 times 1 plus 4 times 3, let's see what happens. Negative 2 plus 12 is 10. 10 is greater than 8. So we wind up with a true statement. Therefore, 1, 3 is a solution, and the other two were not. Okay, and I'll be right back, and we're going to start talking about graphing. Okay, so we're back. I've changed the board just a little bit. So this is an inequality graph, okay? You'll notice we have a straight line, and then we have one side of this coordinate plane shaded. So this line is kind of like Fruit Ninja, and it just sliced the whole coordinate plane in half. So here's one half that represents the solutions, and the other half is over here, okay? So this represents the inequality y is less than or equal to x plus 2. And the only thing we're going to be doing right now is identifying solutions to this inequality. So we're going to figure out whether a point is or is not a solution. So if we look at our definition here, the point is a solution because it lies on the graph. So what does it mean to lie on the graph? Well, here's some examples. This point right here, which is the point 3, 0, lies on the graph. It is in the shaded region of this inequality, so it represents a solution. So 3, 0, if we plugged in just to test it out, 0 is our y value. Is that less than 3 plus 2? It is, because 3 plus 2 is 5. So this is a true statement, which means it should be a solution, and it is because it's in the shaded region. So an example of something that is not a solution would be a point, let's say over here, negative 3, 4. Negative 3, 4 is not a solution because it does not lie on the graph of this inequality. So if we tried by plugging in, which is what we just went over, 4 less than or equal to negative 3 plus 2. Well, 4 is not less than or equal to negative 1, therefore it's not a solution and should not lie on the graph, which is why it doesn't. It's in the non-shaded area. So one last piece that we have to realize is this is a solid boundary line, okay? Our inequality symbol says less than or equal to, which means I can be equal to everything that lies on this line. So if I tried the point, let's see, 2, 4, which lies on the boundary line here, I'm going to plug into the inequality and see what happens. So if I plug in 4 less than or equal to 2 plus 2, I wind up with this scenario. Is 4 less than or equal to 4? In this case, yes, because I am also equal to 4, so that's okay. So this is a solution, which means that 2, 4 does lie on the graph because it lies on the solid line. Okay, and let me change the board. I'll be right back to have another example for you. Okay, so we're back. I changed the board once again. Here's our last example for today. So this is the inequality graph. You'll notice that now we have a dashed line. Okay, this is the inequality that represents this graph. We're going to talk about what solutions look like on this type of graph, where I have a dashed line instead of a solid line, which was the last example we just did. So let's choose the point 6, 1, 2, 3, 4, 5, 6, 3. So based on the graph, without even plugging it into the inequality, we can determine that 6, 3 is a solution to the inequality because it lies on the graph. It is in the shaded region, therefore it is a solution. We're going to verify by plugging it in and see what happens. So my y value is 3. Is that greater than negative 1/3 times 6 plus 3? Once again, if you need to put the right side of this inequality into a graphing calculator, please do so. But negative 1/3 times 6 is negative 2, plus 3 is 1. Is 3 greater than 1? Yes, which means it's true, so we have a solution, which it is because it's on the shaded part of the graph. So now let's try something that is not a solution. If we go to 6, negative 2, it is not a solution because it does not lie on the graph. If we want to check, we can plug it into our inequality and get negative 2 greater than negative 1/3 times 6 plus 3, which you'll notice is the same thing we just did. So I'm going to get 1. Negative 2 is not greater than 1, which means this is false, and therefore it's not a solution, which good thing it's not on the graph. So we have one last point to determine what happens if I'm on the dashed line. So let's take a look at this point right here. That is 6, comma 1. If I plug in 6 comma 1 into y is greater than negative 1/3 x plus 3, I'm going to get 1 greater than negative 1/3 times 6 plus 3, in which I get, is 1 greater than 1? No, 1 is equal to 1. Our inequality symbol does not allow us to be equal to 1 in this case. In the last example, we were allowed to also be equal to 1. Here we're not, which means when you have a point that lies on a dashed line, it is not a solution. You might want to rewind that 10 seconds and listen to that one more time, because that's extremely important. If a point lies on a dashed line, it is not a part of the solution set. So this is false. It is not a solution. Okay? So I hope you enjoyed, and I'll see you next time. Bye.